Hello everyone. You see in this video what is my topic? Increasing decreasing function part 2. It means you have to see part 1 to understand increasing and decreasing function, because in the part 1 I have given a complete introduction of increasing and decreasing function. So no problem, I am just revising that if we have to show in a particular interval that the function is strictly increasing, you have to show that its derivative is positive. If there is written only increasing, then we can also suppose strictly increasing, that is f dash x is strictly greater than 0, and obviously for strictly decreasing we will have derivative strictly less than 0. So there are two types of function. One kind of functions are monotonic function, which will either increase or decrease. It means that in entire domain function will either increase or either decrease. But we have such functions whenever the function is changing its nature from increasing to decreasing. So such functions are not monotonic. So we have a function, and here we have a question that find the intervals in which this function is strictly increasing. It means this function is increasing as well as decreasing. So we have to find out the portion of the real line, that is that interval in which the function is increasing. So it is very interesting that we have a curve and we have to find out the interval in which function is strictly increasing. To check strictly increasing or decreasing, we need to find derivative. So we will find derivative, that is f dash x. So differentiation 3x square, which will become 6x square minus 6x minus 36, and we can take 6 as a common, then we have x square minus x minus 6, and then we can get the factor by splitting the middle term. You know it very well, that x minus 3 and x plus 2. So this is our derivative. Now you know that function is strictly increasing when f dash x is greater than 0. This is the condition. So this is our f dash x. Now we will put, that is 6 into x minus 3 x plus 2 greater than 0. The law of inequality. If you are dividing any inequality with a positive number, inequality sign will not change. So we are dividing both sides by 6, then we will get x minus 3 and x plus 2 greater than 0. Now the story will start. How to find that interval? This is a procedure of algebra. You have to understand that how we will find the interval. Now, because this is a polynomial function, it is a real valued function, it means we have whole real line. We have whole real line, minus infinity to plus infinity. Now, this real line, because we have two linear factor, due to these two linear factor, we will have two puncture point in the real line, and this way this real line will divide into three intervals. So where we have to do the puncture on the real line? First of all, see this factor. If I am putting it 0, then x is equal to 3. It means I can say at x is equal to 3, this factor will become 0. So I have a point 3. Then if I am putting this factor equal to 0, then I will get x is equal to minus 2, which is another puncture point in the real line, minus 2. If I am seeing order, then minus 2 will come first, then 3. So I will mark these 2 points on the real line. First is minus 2, then 3. Now we have divided, this way we have divided whole real line into 3 portions. Minus infinity to minus 2, then minus 2 to 3, and 3 to infinity. Now what is the procedure? You have to choose sign. This is the rightmost interval, so start from the positive sign, then negative, then positive. So because fx is increasing when f dash x is greater than 0, it means whenever the product of these two is greater than 0, that is we have to take positive sign. And where we have the positive sign? In these two intervals. It means here we have f dash x is greater than 0, and in this interval we have f dash x greater than 0. It means in this function is strictly increasing, and in this function, in this portion of the interval, function is strictly increasing, and in the rest of the part, function will strictly decreasing. So we can write function is strictly increasing when x belong to, so this portion is called minus infinity to minus 2 union then 3 to infinity. So this is the portion where the function is strictly increasing and strictly decreasing when x belong to minus 2 to 3. So in this portion the function is strictly decreasing. So this way we have found the intervals where the function is increasing and where the function decreasing. So to understand more, see one more question. Now see this question. In this question also we have to find interval where this function is strictly increasing and strictly decreasing. So we have given a function, to check strictly increasing or strictly decreasing, you need to find derivative of the function. So we are going to find derivative, that is f dash x, and we will use product formula, that is x plus 1 whole cube, as it is the differentiation of this portion, which is 3x minus 3 whole square, then x minus 3 whole cube as it is, and the differentiation of this, which is 3x plus 1 whole square. Now see, in these two terms we will have a common, which is 3 and x plus 1 whole square and x minus 3 whole square. Then in the inside the bracket we will have x plus 1 and plus x minus 3. So after solving, we have 3x plus 1 whole square, x minus 3 whole square, and you can say 2x minus 2, and I can take 2 common from here. So x minus 1 and 2 into 3, 6. So this is my derivative, that is f dash x. Now the function is increasing or decreasing will depend upon the sign of f dash x. So fx is strictly increasing or simply increasing when f dash x is greater than 0. It means this 6 into x plus 1 whole square, x minus 3 whole square, x minus 1 greater than 0. And because 6 is the positive number, we can divide both sides by 6. So we will have again this inequality. Now see, these terms are having a square. This is the special case, so I have chosen this question to solve. This is a special case where students often confused, because these factors are having a square, so there is no matter that they will be negative. They can never be negative. X plus 1 whole square and x minus 3 whole square will never be negative. The only problem is that they will be 0. And for strictly greater than 0, strictly increasing, we should have strictly greater than 0. So we should save this function to becoming 0. So I have to say that if I am not taking x is equal to minus 1, then this factor will never become 0. Now this factor will become 100% positive. I can say this factor will become 100% positive because I am not taking minus 1. Similarly, if I am not taking x is equal to 3, then this factor will also be positive. So these two factors are positive providing if I am not taking x equal to -1 and x is equal to 3. So if x is not -1 and x -3, so this implies x -1 is greater than 0, that is x is greater than 1. So this way whole real line -infinity to infinity has divided into two portions, greater than 1 and less than 1. So we have this is 1. So the function is strictly increasing for greater than 1 and strictly decreasing for less than 1. But there is a problem that after 1, whenever function is strictly increasing, then we should not take x is equal to 3 because it was our initial promise with the function that we will not take x is equal to 3. So where 3 is, so we should exclude this 3 from the interval. So we can say the function is strictly increasing 1 to infinity except 3. 1 to infinity except 3, and we can write 1 to infinity minus 3. And another way to write this interval that is strictly increasing when x belong to, so I can say 1 to 3 union 3 to infinity. This way I can bypass 3. It means in this interval I am before 3 and this interval I am after 3. This way I have excluded 3 from the portion. So in this interval function is strictly decreasing. Now the function is strictly decreasing, this function is strictly increasing and function is strictly decreasing -infinity to 1. But we have promised that we will not take x equal to -1. So we have to exclude -1 from the interval. We have to exclude this value. So now how can I write? So -infinity to -1 union -1 to 1. -1 to 1. So this way I have bypassed -1. So in this portion the function is strictly decreasing. Now we will do some trigonometric question of strictly increasing and strictly decreasing.